Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about JFET biasing. So first of all, let's see the difference between BJT and JFET. So BJT is the bipolar junction transistor and JFET is the junction field effect transistor. So BJT has base, collector and emitter terminals, and JFET, in this symbol we can know that it consists of gate, drain and source. So what is the basic difference between BJT and JFET? So BJT is the current control device and JFET is the voltage control device. So small change in the base current controls the output collector current in BJT. In FET, gate voltage controls the current flow through the drain to source. So this is the basic difference, and BJT has both majority and minority carriers for this operation, and FET uses only majority carriers. And we have N channel and P channel in JFET. So before going to the types of biasing of JFET, let's see the importance of operating point. So operating point essential for to choose the region of operation. So the biasing indicates the application of DC voltage. So we are giving external DC power supply to fix the current and voltages in the field effect transistor, and for transistor amplifiers the resulting current and voltage defines the operating point on the output characteristic of the curve. So this defines the region of operation where the amplification takes place. And next, let's see the biasing methods for JFET. So mainly there are three basic types are used for biasing the junction field effect transistor: fixed bias, self bias and voltage divider bias. So these are the basic three types of biasing methods. So in this, let's discuss one by one. So first one is the fixed bias circuit. So this fixed bias circuit is the simplest biasing method because we have only less number of components in this circuit. So in this you can see that there is a supply VDD, it is connected to the resistance RD and it is given to the drain terminal, and similarly another supply VGG is connected to the resistance RG, gate resistance, which is connected to the gate terminal. So this makes the gate source junction as reverse biased. So JFET is operated in the gate source reverse biased condition, and we have Vi is the input signal, V0 is the output signal, it is connected through the coupling capacitor. So here this method is known as the fixed bias. Here the bias given to the gate is the fixed value. So this is the cost effective method, but the limitation of this fixed bias circuit is it is not stable. So the stability is poor in this fixed bias method. So for the analysis of fixed bias, we use the Kirchhoff's voltage law. So here for the gate circuit, when we are applying the KVL, we get VGS equal to minus VGG. Gate to source voltage is equal to minus VGG, and drain current is given by IDSS, which is the saturation current, 1 minus VGS divided by VP the whole square, where VP is the pinch off voltage. This is an activity. So for the given circuit, we need to find the quiescent current, which is IDQ, drain current value. So by applying the KVL for the drain to source circuit, we can find the IDQ values. So next we are going to discuss about the self bias method. So this self bias eliminates the need for dual power supply as we used in the case of fixed bias circuit. So here we used VDD external power supply. It is connected to resistance RD to the terminal drain, and we use RG and RS connected to gate and source terminals. So this self bias is the stable method compared to fixed bias. So to analyze this self bias, we apply KVL to the gate to source circuit and also for the drain to source circuit, and we get gate to source voltage as minus ID into RS And similarly drain current and drain to source voltages. VDS is equal to VDD minus ID into RS plus RD. So next method we are going to discuss is the voltage divided bias. So in this biasing method we use the potential divider circuit R1 and R2. Here gate terminal biasing is given by the VDD and it is the potential divider circuit and RD and RS is connected. So this is the best biasing for achieving the stable circuit. So equivalent circuit is can be drawn by applying the voltage divider rule. So by applying voltage divider we get gate voltage as R2 divided by R1 plus R2 into VDD. So this can be redrawn using the Thevenin equivalent circuit. And by applying the KVL on both sides we get VGS as VG minus ID into RS and drain to source voltage, drain voltage and source voltage. So let's discuss the assessment. List out the biasing methods for JFET and compare the biasing methods of JFET. Thank you for listening this lecture.